Okay, so now that you're back, I'm going to look at example number 112 in your book. It's the same type problems that I was doing in the previous video. So on number 112, oh, come on, annotate. Number 112, they give us f of x equals x plus 2 times 2x squared minus 3. And they are asking us to take the derivative of this. You do have a couple of options. You are well within your right to multiply this thing out before you start. So you could go through and distribute out your x, distribute out your 2, and then take the derivative of it. I'm actually going to show you how to use the product rule. And I'm going to teach you the way that I learned years and years and years ago. And eventually you're going to stop doing it this way. But this is just a really good way to have it wrote out so you can see it. So the first thing that we're going to do is we're going to identify what f of x is and what g of x is. So f of x is that first function that I have. So that's the x plus 2. And I know it's weird, we've got f of x equals, you know, I could change that to be y, whatever. It's just, I'm trying to follow the rule. So I could have like g of x and h of x, but I want you to see the rule and I want you to use the rule. So that must make g of x to be 2x squared minus 3. So let's change this to y for just a second. We'll just say this is y. That way it doesn't look quite as confusing because f of x is y. So now I also need to find f prime of x and I need to find g prime of x. So in other words, I'm going to take the derivative of both of these. I'm going to take the derivative using the power rule. So the same thing that I did with the previous examples. So when I take the derivative of x, remember your exponent's 1, the 1 comes down, the derivative of x becomes x to the 0. So it's 1 times x to the 0, which is just 1. So really, when I take the derivative of this, I get 1. And then when I take the derivative of g of x, well, this 2 is going to get multiplied by the 2 that's already there. So 2 times 2 is 4x. And then remember, you drop a power, so you subtract 1 from your exponent. 2 minus 1 is just 1, so I really don't need the 1 there. And then I've got minus 3. Minus 3 is a constant. When I take the derivative of the constant, since there's no variables associated with minus 3 at all, the derivative of minus 3 goes to 0, so I don't even have to put anything. All of these pieces of information are what you need to be able to set up the product rule. Again, how did I know it was a product rule? I'm multiplying two things together. So to find y prime, remember it's f prime of x times g of x. So f prime of x is 1 times g of x, which was 2x squared minus 3. So that's the first part. And then it says add to it f of x, which is x plus 2, times g prime of x. Now, please pay attention here. It doesn't matter what order you do this multiplication in. What you have to remember is that f of x and g prime are going to be multiplied together. F prime and g of x are going to be multiplied together. And because it's addition, the order that you do this process in makes no difference whatsoever. That is not the case with the quotient rule, which we will see. So we're going to get y prime equals 1 times 2x squared minus 3. It's just 2x squared minus 3. Plus, here I need to distribute out my 4x. So I'm going to get 4x squared plus 8x. So y prime is going to be equal to, it looks like 6x squared plus 8x minus 3. And again, that's the product rule. Did you have to use the product rule? No, you could have multiplied x plus 2 times 2x squared minus 3 out from the very beginning and then just use the power rule. But there will be cases where the product rule is actually easier to do than multiplying it out. All right, so that's number 112. I'm going to do a really weird example of 113. I'm going to clear this out. Number 113. Same directions, we're asked to find the derivative. So they give us f of x equals x squared times 2 over x squared plus 5 over x cubed. Now, again, this is a product, right? I've got x squared times the stuff in the parentheses. So I could go through and designate x squared to be f of x. This 2 over x squared plus 5 over x cubed to be g of x. I could rewrite both of those in, or the 2 over x squared plus 5 over x cubed to be 2 x to the negative 2 plus 5x to the negative 3, cleaning up the denominators here. I could do all of that, but that sounds like a lot of work. And one of the reasons that I think that sounds like more work than it has to be is if you notice, you're multiplying by this x squared, right? And you've got an x squared and x cubed on the bottom. I think instead of doing all that, this go around, unlike last time, I'm just going to distribute it out and see what happens. So notice I haven't taken a derivative. I'm just doing some products here, right? I'm just multiplying. So if I do x squared times 2 over x squared, that's going to give me 2. The x squared cancels out. And then if I multiply x squared times 5 over x cubed, that's going to give me 5 over x. It already looks prettier than it did. Again, I've not taken a derivative. I'm just trying to clean everything up. So I'm going to rewrite this 2 plus 5 over x to be 2 plus 5x to the negative 1. I really don't want to leave 5 over x because if you do, that's a quotient rule. And if you notice, with these problems, I'm trying to take the easiest way possible out of this. So that's what I'm doing. All right. So if I go in and take the derivative now, so if I do f prime of x, this goes back to those examples in the previous video. If I take the derivative of, and this is what I'm taking the derivative of, if I take the derivative of 2, I'm going to get 0 because that's a constant. And if I take the derivative of 5x to the negative 1, that's the power rule. So I'm going to take that negative 1, I'm going to multiply it by the 5 and get negative 5x. And then remember, you just subtract 1 from the exponent. So negative 1 minus 1 is now negative 2. So we end up with f prime of x being equal to negative 5 over x squared. Again, you could have done the product rule if you had wanted to. It was a lot more painful. So I want to show you that with this stuff, you have options. So you want to take the easiest option. And that's why we learn all of our exponential rules. That's why we learn the product rule, the exponential rule for that, or your power rule for derivatives, your quotient rule. We want to have all these different things at our fingertips so that we can figure out which one's going to be the easiest for us to use. So that's 113. I think I'm going to do one more example in this video and then I'll start a new one. Yeah, because we changed directions. Try not to overwhelm you with all this information on one video at a time. So I'm going to do number 117. So number 117, they give me f of x equals x plus 9 over x squared minus 7x plus 1. Now, normally I'd try to find a way to clean this up. The only way that I could possibly clean this up is if x squared minus 7x plus 1 factor. And it doesn't. So trying to factor and cancel things out is not going to help me. So here, I actually have no choice. This is going to be a quotient rule. So you've got the top x plus 9 divided by the bottom x squared minus 7x plus 1. So I'm going to do the same thing I did with the product rule. First thing I'm going to do is pick out what represents f of x, g of x, f prime of x, g prime of x, and go from there. To make it a little bit easier for us to see, I'm going to change f of x to be y. That way we're not getting confused with the fact, oh, this equation is named f of x and we're looking for f of x. I don't want any confusion with that. So f of x, according to the formula, is represented by what's in the numerator, which in this case is the x plus 9. G of x is represented by what's in the denominator, which in this case is x squared minus 7x plus 1. So now I also need to find f prime of x. So if I go through and take the derivative of x plus 9, remember this is the sum or difference rule. So I can take the derivatives of each individual thing. The derivative of x, as we've seen about 3 times now, is going to be 1. The derivative of 9 is going to be 0, so I don't have to include it. So let's talk about the derivative of g prime of x. Again, sum and difference rule. So if I take the derivative of x squared, that squared is going to go down in front of the x. And then the 2 is now going to become a 1. Let me pull out my 7. Well, so here if I take the derivative of negative 7x, this x has an exponent of 1. 1 times negative 7 is negative 7. And then we've got x to the 0. Of course, x to the 0 is going to be 1. And then finally, we take the derivative of 1. The derivative of 1 is 0. So we find out that the derivative of g of x is actually 2x minus 7, because the x to the 0 goes to 1. Okay, so with that in mind, I'm going to now plug this into my derivative equation. So y prime is going to be equal to, it was the derivative of f times g of x minus f, which was x plus 9, times g prime of x, just 2x minus 7, over g of x squared. Let me do it like this, x squared minus 7x plus 1 squared. So again, I want to remind you, it does make a difference how these things go out in because of that minus sign in between these two statements. So you do have to pay particular attention if you've got your f prime times g of x and then f times g prime of x in the right order. I'm going to, because I'm almost out of room here. So guys, to work this one out, we'd have to distribute out the 1 here. So I'd give the 1 to everything. Here I'd have to multiply x plus 9 times 2x minus 7, multiply that out, and then distribute out the negative. If you do all that, and I want you to pause the video and I want you to do this. So I want you to take a moment, do the math, because what you're going to find as we go through the rest of this chapter is our algebra skills have to be on par. These problems are going to be highly algebra intensive. So here, if you go through all of that math, you should end up with on the top negative x squared minus 18x plus 64. And that's over. Now notice, I'm not going to touch the bottom. I'm going to leave x squared minus 7x plus 1. So here's kind of the standard that seems to be happening with your Newton Alta. They want the numerators cleaned up as much as possible, but if there's no chance that anything's going to cancel, and there's not, this x squared minus 7x plus 1 is not going to be pretty. They just leave the denominator the way it is. So they leave it x squared minus 7x plus 1 squared. So clean your numerators up. For the most part, we're not going to touch the denominators. All right, guys, so that's video 2. Come back and we'll do some more.